Hello, students. Let us start.
Sir.
Can you hear me?
Sir.
Okay. If there is any problem, then please let me know. Yes, last class we had discussed about the some definition and something about the starting of the linear programming problem, and I had already told you that linear programming problem. Just prion. Purpose do adu amta hairo haye moy asomda di yawraga moy clarification sangma maleba mana su screenshot thare eba somda khoina main gi purpose do adu amta sapsana hairo haye adu lalaga ding bira ka du janeba nang khoina APC kanogi journal publication na habdu sana ba yaudi na kano to ki haidaina adu nang amtang di hanga try to gera moy pai gan da bane ha soy da vida soy da ado que no toro whatsapp to in thoro ai class to re bus phare okay, let us start. See, linear programming problem. I'll recall some of the things we had discussed last time. Actually, with some small variables, we had already done with 2 variables only. 3 variables. It was difficult to us at the time, but now with the simplex algorithm, we will solve the problem with any number of variable, any number of equation here. And then for that also, see. See. Here we are considering an equation with what n variable and the m equations, and this type of the n may be any number, and that is why we are writing in a general way. This type of problem we can solve according to this simplex method, and there are some algorithm is there. You have to remember that you have to know that algorithm, and with that we have to solve the problem. In the class note also I had given the algorithm, but the thing is that whether you read it or check it. Yesterday I'm not doing the class. I think you might at least see something how it is. How do you feel? Anybody read it or check it? Can you understand? Anybody? What happened? Are you listening me?
Yes, sir.
Have you checked it? Whether can you understand or not? That's I want to know simply.
Yeah, can understand, but explanation would be good. Yeah, can understand by going
Can't
through notes.
understand. Yeah. Many symbols are there,
understand.
many things
Sir,
are written, you cannot
Yeah,
yes,
understand.
sir.
Okay.
but
Mhm.
explanation would be good.
Yes, sir.
Yeah. Explanation
Yes,
will
sir.
be necessary. Definitely. Mm.
First time, sir, in reading, sir, some difficulties are there, so explanation will
Yeah.
be.
Okay. This I want to know. Firstly,
Sir,
what
sir,
you have
someone is
to
trying
know
to
is
join.
that from
Hello, sir.
this problem, it
Sir,
will
hello.
change to a table form. Table form is already given here. I given here the table form. This is in page some see
Sir,
here.
hello.
This is the table form. In this table form,
Sir,
from the
someone
problem
is trying to
given
join.
to us, we have to transform to this table with the entries here. Mostly this will be the numerical entries. This will be numerical entries. This up to this is the numerical entries. And these are the name of the vectors. And this also will be numbers. And this also will be numbers as well as some name. And these are the notations. And this is what we have to calculate. This is to calculate. This row we have to calculate. And then same table we will come in the next step also. Similar table will come in the next step, and how that is to be done, this we have to know. And in this there are something which you have to know before coming to this. And firstly, I told you before coming to this table, our first thing is to write the linear programming problem in the standard form. And how we have to write it in the standard form? General form, it may be either with less than or equal to or greater than or mixing. Or mixing also maybe. But in the case of in order to use for the simplex table, it should be in standard form. Standard form means there should not be less than equal to, there should not be greater than equal to, it should be only equal to. It should be only equal to. It should be only with equal to. And then after obtaining that, after getting that, we have to start the problem. Say for example, problem should be like this. Oh, here problem is exercise. Okay. Problem should be like this: maximum z this, and then with this equal to. And if it is so, if it is in this form, then we can write it in the table form. Otherwise, it cannot write. It should be equal to, not only equal to. And in order to make it, we have to add the slack variable or surplus variable according to the condition of the problem. And slack variable, surplus variable, I told you they are all positive variable. One is added to the constant where less than equal to sign is there, and another is subtracted to the constant where where it is greater than equal to. Those are the differences. They are all positive variables. Okay, and then after first thing is nothing to calculate. Only from this form. From this form, we have to write everything. We have to transfer. We have to fill up this table. And how that is to be filled up, I'll tell you in a step-by-step method. That is also one of the part of the algorithm. And then okay, in order to do that, I think it is better to start with the algorithm first. By reading with the algorithm, by studying with the algorithm, you may not able to understand, but let us at least know something what is that one. See, let us start with this now. Okay, simplex algorithm. LPP can be written in the matrix form as follow. Whatever we have written is the expanded form. It can be written in the matrix form. Matrix form means this is for objective function. Objective function can be written as CTX. CT is constant coefficient. X is the variables. And then subject to constant. All the constant equations that can be written as a single matrix as A matrix multiplied by a column matrix X equal to another column matrix B. And all the X variable are greater than equal to 0. And where we can write A as like this: A1, A2, AN. A1 is the A1 is the first column, first coefficients of the first columns. Coefficient of the, you can say, better to say, in order to understand, coefficients of the first elements, say like x11, x21, x31, like that. And then A2, coefficients of the second elements, second term, coefficient of the second term, better to write. This is coefficient of the n term. And is AJ means A1 also, A2 also, AM also. They are all m by 1 vectors. And let us assume as before m less than n. Thus, we can choose at most NCM ways to form a basis. And NCM ways means, see, I had already told you, I show with an example that 2 equations with 4 variables, we can solve it. How many solutions it have? See, we had already discussed last time an equation with a system of equation with 4 variable 2 equation. How many solutions are there? In order to solve it, we are taking 2 variable 0, 2 variable 0, remaining we solve. And it is given by NCM, means 4C2. Combination is to be calculated, 4C2. 4 is total number of variable. Combination 2 means number of equation. And that calculation is 6. That is why we got 6 solutions. And same thing here, in general also, thus we can choose at most NCM ways to form a basis. MCM ways to form a basis means, basis means what? Number of excess variable that we consider as 0 and we find the solution. That process is called forming of the basis. The solution is one of the basis. And then in that way, we can have 6 ways of forming the basis. And let the current basis be, let this be the current basis. This be the current basis. B equal to B1, B2, Bm. And where here basis, regarding the basis will be a part. See, I already told you in this table, in this table, no, not this. Okay. See, let us come to the table. In this table, this portion is the fill up by the coefficients of the constant, coefficient from the constant equations. And in this, as we had already added slack variables, then this portion, last portion, will have a form of like this. First column element 0, first column element 1, second 0, third 0, fourth 0, like that. First row, sorry. First row 1, second 0, third 0, fourth 0, like that. And next one, first row element 0, second column 1, third column 0, like that. And next one, first, second 0, and third row 1, like that. That means in the form of a identity matrix, we will find that will be the basis. That is what it is represented by B here. But everything will be easier when we come with a numerical problem. Numerical problem, I will show you, and then you also will understand it very easily. It will not be today, it will be next week. By Monday, I will do that. But for today, let us at least know something. What are the things written here? And where clearly BIs in 5 are some AIs in 4, at any stage of the iteration, the change in notation from AI to BI met above is done for not to give any preferential treatment to any set of AIs. Thus, once M number of AIs are chosen from A, this, to form the basis B and are given name BI, this would be
Sir, someone is trying to join the class, sir.
Hmm. Okay. Can you see the screen? Can you see the screen?
Yes, sir.
Yes, sir.
Okay. Then. Okay. Now, there's once M number. These are chosen from this from the basis B. Yes. To form the basis B and are given name Bi, there would be n minus m ai's left in A, which would be called non-basic vectors. Others are non-basic vectors. And therefore, at any stage of the iteration, non-basic vectors are not included in the basis B because they are non-basis, and that is why only basis will consider, non-basis will not come to the basis. And thus, for any choice of the basis matrix B, we get determinant of the basis matrix B should not be equal to 0. That means B inverse exists. There is the theoretical part, how it comes, the theoretical part. That is actually, for examination point of view, it is not necessary. But the thing is that you at least know how is the process. And secondly, Bx inverse equal to B. And that is, if you want to find xb, then it will be B inverse B. That your target is to find the xb because you have to find the values of the variables, and that variable will be represented by xb. And where xb transpose is this, and the bxbi's is the I component of B with b1, b2, bm as the basis vector in Rn. We shall justify 7 in the following manner. From 1 to 3 and 4, we get this. 1, 2, 3, and 4. Equation 1, 2, 3. 1, 2, 3. 1, 2, 3. And this 4, we will get this. And now, whenever we choose m basis vectors out of this, we identify their coefficients xij's and call them xb1, xb2, and xbm. Coefficients are, we are calling like this, and put the other remaining n minus m xj's to 0. And now 7 can be written as in this form. 7, it is this. This 7 can be written as in this form. Because what is 7 here? 7 is bxb equal to B. Now it can be written as like this. Bxb is this, that is equal to B. And if all xbi's greater than equal to 0, that is non-negative, then xb would be a good candidate for finding the maximum value of z. Since determinant B not equal to 0, we get from 7 xb equal to B inverse B. And we have by assumption B greater than equal to 0. See, I had already told you all B should be 0. In order to make to the standard form also, B should be 0. If B is negative, multiply by -1 and change it. But there is no for theory that B inverse B, that is xb, is non-negative, but x should be non-negative. That is not the case for any choice of B. And however, if the solution of LBP given in 1, 2, 3 exists, we shall find that there exists at least one choice of B such that xb is given by B inverse B. It should be positive or 0. This xb is the basic feasible solution of 2 and 3. Thus, looking at the constraint 2 and 3, we see that at most m numbers of xj's, that is xbi, is in 11 exists, and the n minus m xj's are zeros for any choice of the basis matrix B. And that is for any choice of the basis vectors b1, b2, bm. And again, with this choice, z becomes like this. And this becomes z is this, because cj will be this, for particular cj will be this, and xj will be this. And this means that for keeping parity, we write xbi for those cj's for which xj's are changed to xbi. and the summation falls from n as in 12 to m as in 13. Since n minus m, x's are simply 0. And however, the process of remaining of CJs to CBIs needs some clarification. We know that in the above process, we can perform following step. Let us see the step here first. What are the steps for this algorithm? Choose m numbers of AIs. Out of that AIs, you choose m number. AIs means the AIs out of n. Out of those n AIs, you choose m number. That means, see, in one example we had discussed last time, we have 4 variables. Out of that 4 variables, we select n minus m variables. Likewise, the same thing here, and 4 and 2 that comes here. And then a1, a2, an, and rename them as a1, a2, am, rename them as b1, b2, bm, and such that determinant b not equal to 0. This is the important point. Determinant b is not equal to 0. It is possible in case of identity matrix. Identity matrix is never 0. And that is why our best choice will be identity matrix. And where b is b1, b2, bm. And step 2, what is that? Put all other n minus m xj's which are not associated with b1, b2, bm to 0. Others is 0. And rename the remaining xj's which are associated with b1 and the b2 to bm as xbi. And such that summation I from 1 to m xbi b1 equal to b and xbi greater than equal to 0. Clearly, xbi's are the components of b in the basis this. And step 3, in z equal to this, rename the corresponding xj's as xb's, as is done in step 2, and put the other n minus m xj's equal to 0. And now, corresponding to these xbi's, the corresponding cj's are renamed as cbi's. And step 5, once the cb's are known, the current value of z can be calculated as in this way. See, actually this is the step you have to follow. But whatever written here, whatever I read, I think you will not understand. And only the thing is that by doing practically the problem, by solving the problem practically, you will understand. Algorithm, whatever the procedure they had given, it will be if you read again and again, it may you will digest. But the thing is that it will be difficult to digest, and that is why I'm not interested all these things, all these algorithms and all these theories. And what I have to do is that I'll practice with you with exercise. With the exercise we will do together, and you also try to understand while doing that, because many of the problem, not only this linear programming problem, integer programming problem, and then big M method, all will have the same procedure. That is why once you know this, you will know for the remaining 2 other problems. And that is why while we are practicing with the actual problem, you try to understand. If any difficulty is there, any doubt is there, you try to clear it immediately. And I will not solve only one problem. I will not discuss with only one problem. As it is online, I have no option but to solve problem. But anyway, we'll discuss as possible as problem we can, and then let us try to understand it. And until and unless you do not understand, you don't hesitate to ask me the questions. And you can interrupt anytime when we made the discussion. See, I want to show another slide, but that slide is not prepared today. I will prepare it next time. But let us start something with this one, and so that you can see whether you can understand or not. See, this is the first table we have to make. First table we have to make from the numerical problem given to us. And these are what I told you we have to fill up from the question given to us. And this also. And these are the values given. Regarding this, what I told you in the procedure what is written as xb should be like this to be replaced, cb should be take 0, and basis should be like this. This is the basis. And now let us go to the problem first, and then let us come to this table again. See, this is the problem. This is the problem, and this is the problem written in the standard form. In the standard form, this is the slack variable added, and this is also slack variable added, and with those two slack variable x3 and the x4, objective function changes to this form: 0 into x3, 0 into x4, and another 0 into x4, 0 into x3 is added, because we will make this with 4 variable, this also 4 variable, this also 4 variable. And our target is to find the values of x1 and x2. With that x1 and x2, we find the maximum value object. Whatever obtain the value of x1, x2 obtained here, that will satisfy the condition, and that will be the maximum. And in the case of what you had already done in the graphical method and other thing, you will search the corner point, or the what I have to say, vertical points, and those vertical points are all the vertical points will be considered, and you will find the values of z for each of the vertices, and the maximum will be the maximum, minimum will be the minimum. In that way, here nothing is not necessary. Only from here we have to find the value of x1 and x2. That will be the solution, and with that value of x1 and x2 we will find the z. That will be the maximum. That is what we have to do. This is the modified form. From here you have to consider this one, this first row, this equation, this part, and another one, this part and this part. With these three, you will fill up the table first. Only fill up, and I will call this as first row, or let us denote it by objective. This is the objective function, and this is the first row, this is the second row. I will say in that way. Then let us come to the table, how it comes. See here. From that objective, we will get 5, 7, 0, 0. Let us see whether it is objective function. Objective is coefficient are 5, 7, 0, 0. Column are first column, second column, third column, fourth column, row. This is the objective function. This is first row, this is second row. Then this is from the objective function. First column, first element, second element, third element, fourth element. We are considering only the coefficients. Then we are seeing A1, A2, A3, A4 vector. This is the A1, A2, A3, A4. If more, then you can write A5, A6 like that. And this is from the first row of the constraint, and this is from the second row of the constraint. Let us see to the problem again. See, what is coefficient of first row here? 2, 3, 0, 2, 3, 1, 0, and another is 13 after equal to. Then it will come here. 2, 3, 1, 0. 13 will be here. 13 will be here. XB. 13 is XB value. And likewise, this is from the second row, and 12 is this value. This is fill up of the table. And in this problem, marks will be given step for each and every step. So suppose we ask a problem for filling up this table, at least you will carry some mark. Stepwise, it will be distributed. Okay. Then this is, and after that, we have to do this calculation. And that calculation part I will do later on. And one thing I want to tell you again, here see, I told you there will be a part where identity matrix portion is there. You see this. Whether this can be the identity matrix or not. This is the first column of the identity matrix, second column of the identity matrix, and this is what we call B. And B here, it is composed of A3 and the A4. This will be the basis. And this A3 will go here as A3, value 0. This 0 is from where? This 0 is this. A3 is having 0, that is why we are writing 0. And another A4 is this, it is 0, that is why it is 0. And while while selecting this A3, A4, this BB, BB, it will be from such things. You cannot write here A2 because A2 is not part of the, A2 is not a column of the vector of the, A2 is not a vector of the identity matrix. And A1 is also not the vector of the identity matrix. And that is why A1, A2 cannot come here. Only A3, A4 will come. So suppose it has 4 rows, 4 rows, first, second, third, fourth. Then another A5 will come, A6 will come, and here it will be like A5, A6 like that. Are you clear up to this? Is there any doubt? Anybody, any doubt? If I continue further, then you may not able to understand, and that is why for today I want to stop here. Okay, let us meet next week, and in that one important slide will be shown to you, and with that how you are coming like this, that will be more clearer. And today the slide is missing in my laptop, that is why it is not possible. And okay, let us stop here for today.
Okay.
Okay. Come on.